What if the very heart of our world, a colossal sphere of iron hotter than the sun's surface, suddenly changed its rhythm? Imagine that deep beneath your feet, thousands of kilometers down, this immense engine paused its eons-long dance. What if it stopped spinning, or even began to turn the other way? This isn't a question from a science fiction script. It's a hypothesis that emerged from scientific observation nearly a year ago, sparking both intense debate among geophysicists and a wave of public anxiety. We live our lives on a thin, fragile crust, blissfully unaware of the titanic forces churning below. The question we must now confront is a profound one. Has a fundamental shift in our planet's core already begun to unleash chaos on the surface? The Earth's inner core, a solid ball of iron and nickel, about the size of Pluto, spins within a liquid outer core. For decades we believed it spun slightly faster than the rest of the planet. But recent seismic data, the echoes of earthquakes traveling through the planet's depths, have suggested something startling. These studies propose that around the year 2009, the core's rotation began to slow down, eventually matching the pace of the surface. Some scientists even speculate it might now be in the process of reversing its relative direction. This isn't just an academic curiosity, it's a potential shift in the fundamental mechanics of our world, a planetary gear change of epic proportions. We are passengers on a cosmic vessel, a complex and interconnected system where the deepest, most hidden engine room could influence everything on deck. Could this subterranean shift be the unseen hand behind the recent surge of violent earthquakes and spectacular volcanic eruptions we've witnessed? The whispers from the deep earth have become a roar, demanding that we listen, that we investigate, and that we understand the forces at play. To grasp the magnitude of this potential change, we must first journey to the center of the Earth. Imagine peeling back the layers, first the thin crust we live on, then the vast, slow-moving mantle of rock. Deeper still, we reach the outer core. This is a roiling ocean of liquid iron and nickel, a metallic sea where temperatures soar and immense electrical currents generate our planet's protective magnetic field. This magnetic shield is our silent guardian, deflecting harmful solar radiation and making life on the surface possible. At the very center of it all lies the inner core. It is a solid sphere, a world within a world, under pressure so immense that the iron cannot melt despite being hotter than the surface of the sun. This solid core is not locked in place. It floats within the liquid outer core, free to spin at its own pace. For a long time, seismic wave studies suggested this inner core was outracing the rest of the planet, completing an extra rotation every few hundred years. This differential rotation is a key piece of the puzzle, influencing both the liquid outer core's flow and the magnetic field it generates. It's a dynamic spinning heart that drives the planet's hidden lifeblood. So what happens if this spinning heart slows or reverses? Think of it like a complex gear system. If a central gear suddenly changes its speed or direction, the effects ripple outward. A change in the inner core's spin could disrupt the intricate convection currents in the liquid outer core. More immediately, scientists theorize that the gravitational coupling and magnetic coupling between the core, the mantle, and the crust could be affected. A change in the core's momentum could transfer stress to the layers above, potentially influencing the behavior of the tectonic plates that float on the mantle. To understand how a change deep inside the Earth could cause disasters on the surface, we need to talk about a force you experience every day: centrifugal force. The Earth's rotation creates this same force on a planetary scale. It's strongest at the equator, it's weakest at the poles. It's a fundamental reason why our planet is not a perfect sphere. This force is always there, an invisible hand shaping our world from the surface. Now let's apply this concept to the Earth's interior. The entire planet, from the crust down to the core, is under the influence of this rotational force. Think of the Earth's mantle, the thick layer of semi-molten rock beneath the crust. Centrifugal force helps maintain a delicate pressure balance, keeping the vast majority of this magma contained deep below. It acts as a planetary seal, a governor on the engine. That keeps immense pressure and heat from erupting chaotically onto the surface. It helps maintain the status quo of our world. What would happen if that force changed, even slightly? If the Earth's rotation were to slow down, the centrifugal force would decrease. The outward push that helps support the crust and the mantle would weaken. This could allow gravity to pull everything inward more strongly. The planet would become slightly more spherical. This shift could cause the Earth's crust to crack and buckle under strain. The delicate balance holding tectonic plates in place could be disrupted, leading to increased friction and stress along fault lines. Furthermore, a decrease in outward force could change pressure dynamics governing the magma in the mantle. With less centrifugal force holding it down, magma could be displaced, pushing upward with greater urgency against the underside of the crust. This could find release points in the world's volcanoes, leading to more frequent eruptions and more explosive eruptions. In this scenario, a change in the planet's spin isn't just abstract, it's a trigger. The past 6 months have felt unusually turbulent, a period marked by the Earth flexing its awesome and terrifying power. It began in earnest back in March, with the devastating magnitude 7.8 earthquake that struck the coast of Peru. The shallow quake triggered widespread landslides in the Andes, burying entire villages and severing communication lines for weeks. Then, in May 2025, the focus shifted to the Ring of Fire's opposite side. Indonesia's Mount Merapi, one of the world's most active and dangerous volcanoes, roared to life in an eruption more powerful than any seen in a generation. It sent a colossal plume of ash into the stratosphere, and gas kilometers into the stratosphere, grounding flights across Southeast Asia, forcing the evacuation of over 100,000 people. The pyroclastic flows were particularly destructive. Superheated avalanches of gas and rock, reshaping the mountain's flanks and serving as a terrifying display of the molten fury that lies just beneath the surface. The summer brought no respite. In July, a powerful magnitude 7.5 earthquake rattled central Japan, causing significant damage in several prefectures. Shortly after, in August, the seismic spotlight moved to Europe. The Campi Flegrei supervolcano near Naples, Italy, which had been showing signs of unrest for months, experienced a major seismic swarm and significant ground uplift, prompting authorities to raise alert levels and prepare for a potential eruption in one of Europe's most densely populated volcanic zones. Finally, just last month in August 2025, a sequence of powerful earthquakes struck along the Anatolian Fault in Turkey. The largest, a magnitude 7.6, caused widespread destruction and reminded the world of the region's extreme vulnerability. Each of these events individually is a known geological hazard, but their occurrence in such a condensed time frame has fueled public speculation and scientific curiosity. Is this just a statistical anomaly, a random clustering of unavoidable natural disasters, or are we witnessing a pattern, a global surge in geological activity driven by a deeper, more profound change within the Earth itself? When we ponder planetary-scale disasters, our minds often drift to Hollywood blockbusters, and few are as epic in their depiction of geological chaos as the movie 2012. In the film, the Earth's core is depicted as heating up due to an onslaught of neutrinos from a solar flare. This superheating causes the planet's crust to become destabilized, leading to crustal displacement. Continents slide around mega-tsunamis, swamp mountains, supervolcanoes erupt in a spectacular, world-ending cascade of special effects. The film presents a scenario where the entire surface of the planet breaks loose from the mantle below, a geological apocalypse of the highest order. The movie uses the core as its central plot device, correctly identifying it as the ultimate engine of planetary change. The heroes of the story race against time as California slides into the ocean and the Yellowstone caldera explodes. The visual spectacle is undeniable, tapping into our deepest fears about the solid ground beneath us, suddenly betraying our trust. It takes a grain of scientific truth, that the core is critical to planetary stability, and amplifies it into a narrative of complete and utter pandemonium. However, this is where science and fiction dramatically diverge. The premise of the film, that neutrinos could heat the core, is pure fantasy. Neutrinos are ghostly particles that pass through almost all matter, including the entire Earth, without interacting with it. They simply cannot transfer that kind of energy. More importantly, the concept of rapid crustal displacement, the entire crust slipping and sliding around in a matter of days or weeks, has no basis in our understanding of geophysics. The forces required to achieve this are beyond astronomical, and the crust is not a simple shell floating on a liquid layer. It is intrinsically linked to the upper mantle. While the movie's why and how are fictional, it's what captures the imagination because it visualizes the ultimate consequences of geological instability. The current uptake in geological events is occurring a year after the core spin was reported. In addition, the Earth's magnetic shield created by the core spin has weakened to the point of auroras being seen in the mid-United States. Is this timing just coincidence, or are we now seeing signs of that core spin change? Thumbs up if this video got you connecting events, and remember this theory as more prevalent earthquake and volcanic events begin to occur.